question 11. That's just going to be a similar approach again, like we talked previously. So they're asking you, does there exist a function f of x that satisfies these certain properties that they're asking about? So we need, in this case, the f of 0 to be equals to 10. Okay, I don't know why my pen's acting funny. This, we need f of 2 to be equals to 2. I want to make sure that the function's derivative is always less than 1 in 0 to 2. Okay, so given that information, what we kind of figure out has to do is check if the mean value theorem holds or not. Okay, so if you want to check the mean value theorem, you have to see the secant line slope should not exceed 1. Okay, so if you were to write a secant line equation, like secant line slope for 0 to 2, that'll just be f of 2 minus f of 0 over 2 minus 0. Okay, which happens to be, from the given information, you can figure it out to be 2 minus 10 divided by 2, which gives you a resultant of negative 4. Okay, so now we're going to ask ourselves, is the slope that with the secant line, is it satisfying this condition? Is it less than 1? Yes, it is. So yes, fx can exist. Alright, so now we're going to start talking about problems involving the intervals. Okay, since we covered up a bit about these things previously in the other topics, we'll have to start to think about from that reference again. We saw that we concluded if you have a function, so just going to talk about the theory. Let me just change a pen actually, it just makes more sense to do so. So the part that you need to understand from here is if you have a random function, right, let's say like that, the maximum value and the minimum value that happens right here, although they're pretty similar, but you see that there's a little bump here. These points are the points where the function will change its behavior as well. So we know in this context, this point is going to give you, what's happening to my pen? Come on, stop working. It's going to give you a max here, and this point here is going to be the min, the relative max and a relative min, because the absolute max and the absolute min just go beyond the scope. So now what we have to see is, before that point, you saw the function was increasing to its values. I'm going to use this blue color here. The function had to increase to get to that max value. After that it got to the max value, it had to decrease to get to the min. And then after it got to the min, it further on started to increase. Okay, so what we're trying to see here is the behavior of the function changes just before and after the critical point. Critical point, aka that gives you the maximum and the minimum as well, right? So in this case, we're going to start to analyze a bunch of functions, and we have to conclude this information and the intervals from what's given to us. Okay, so in this problem, what we have is a function f of x given out to be as negative 4x cubed plus 18x squared plus 120x plus 4. So now given that function, we need to be able to figure out which interval is it increasing at, which interval it's decreasing at. So in order to figure out the intervals, we need to figure out the critical points first. So we find the critical points. We call them CPs for short here, right? So critical points, how do you find them? You have to just take the derivative of that function, equate it to 0, and solve for x. Whatever x you'll get are going to be the critical points. So let's do so. When you take the derivative of the function, what do you get? You get negative 12x squared plus 18 times 2 must be 36. 36x plus 120. Okay, Given that information, you know to be able to find for critical points, you need that derivative to be equals to 0. So let's put it equals to 0 and solve for the values. So negative 12x squared plus 36x plus 120. Oops, that made that funny. Let me try that again. Must be equals to 0. So when you know this fact, you can factor out 12 from this. So you get negative x squared. When you factor out 12 from 36, I think you should be left with 3. So plus 3x. And then out of that you get 10. That must be equals to 0. So now if you try to factor out this situation right here, you should be able to get 5 and 2. Okay, so negative x squared minus 5x plus 2x plus 10. This is just me doing an old school way of factorization. From this you get negative x factored out. You'll be left with x plus 5. And out of those you factor out 2, you'll be left with x plus 5. Okay, so your x, of course this must be equals to 0. So from this what we get is that either my x is going to be equals to 2 or x is going to equals to negative 5. So these are the 2 points of interest because at these 2 points the function's behavior is going to change. So let's try to see how you can evaluate that using the first derivative test. The next step will just be to be able to put them on a number line and observe the value of the derivative. So put it on number line. The lower point was, I think, negative 2 or negative 5. Let me just double check. Yeah, negative 5 was that. So we had negative 5 and we had a 2. So what we're going to do is we're going to find the value of the derivative for the values in between these zones. Okay, so if you're looking for a value less than, let me just put down the function's derivative here so it's easy for us to kind of compute. Let me go back. And that happens to be right here. So I'm going to put it down. So it's negative 12 x squared and then plus 36x and then plus 120. In the factored form, this will look something like this. You have x plus 5 and you have x minus 2. Okay, these are the kind of things. So not really, you don't have x minus 2, it should be 2 minus x. So a factored form is just going to help us to get to the magnitudes much faster. All we're looking for is the magnitude of f prime of x in between these two. Okay, so let's say you're at negative 5. So you pick a point that's less than negative 5. Let's pick negative 6. Okay, at that point, if you evaluate the value of the derivative, what do you get? When you plug in negative 6, you get negative 6 times plus 5, so that's negative 1. And then, so let's just put it up here. Negative 6 times plus 5, negative 6 plus 5 times, we'll get 2 minus of minus 6, right? So what we get up here is negative 1 times, you have 2 minus of minus 6, you get 8. In this case, your value is going to be less than 0. Okay, so in this zone here, let me just change pens here. This zone here, the function is having a negative slope. So the function is decreasing in that zone because it's coming back down there. Okay, so now let's pick a point in the between the other domain. So let's pick up 0 here. So at that point, when you try to evaluate f prime of 0, when you plug in 0, all you get is 5 times 2, okay, which is going to be greater than 0. So in this case, we can pick up, let me just change the pen. So in this zone, what's happening is the value is increasing, okay, because it's a positive slope, right? Not in just that one. It should be for the whole. Let me just draw it again. So in this whole zone, the value is increasing, okay, because these were the critical points, right? So now I'm gonna label them in like purple so you can have an idea which ones are the critical points. These are the critical points we're talking about. Everything else is something that we pick, okay? So we picked up -6, we picked up 0, we figured those out. Let's pick a value greater than 2 and figure the last interval out. So once we pick up 3, what's going to happen to f prime of 3? When you plug it into the function, you get 8, and then 2 minus 3 will just give you -1, which means it's going to be less than 0 again. So the function will start to decrease again now beyond all of those points. Okay, so when you're trying to write the interval for this answer, they're asking you the function is increasing on which interval. So we'll say it's increasing on the interval that we figured out to be from -5 up to 2. So it's -5 up to 2, which are just the critical points that we figured out as well. And now we have to figure out the decreasing interval. And now it's decreasing. They already gave you a -infinity and then this here. And they also gave you this portion with a positive infinity on the right side. So as we see, if you come in from the number line, you're decreasing for all the values up to -5. Right, so this one will have -5 plugged in there. And then you start to decrease for all the values above 2. So this will be from 2 to infinity. So that's how you kind of figure out the intervals. Now the last part of the asking is the function has a local maximum. So remember, for a max, what kind of behavior are you expecting? You want the slope to be going like this, right? So the slope must be positive, 0, and then negative. So where does that happen? If you look at 2, right? So if you look at the value at 2, the other critical point, because we only have two choices, right? We have either -5 or 2. The maximum is either going to be at -5 or 2. So in order to see, if you see 2, the slope was positive before that, it becomes 0, and then it starts to decrease right after that, right? So technically, from that information, you can see the function has a max. Technically, more specifically, is local max at x equals to 2. And that's how you conclude how to find intervals for our question here. Now let's talk about problem 13 again. Similar approach, exact same procedure. Let's try to get a hang of it. So now the function in consideration here is -2x cubed plus 27x squared and minus 108x plus 8. So in order to find the intervals of increase or decrease, we have to still do the same analysis. So we'll figure out the critical points first. So we have to figure out the derivative. The derivative of the function is a -6x squared. 27 times 2 is going to give you 54x minus 108. Okay, so when you factor out 6 from this, what you can write is, so first, let's not factor it out first. You have to make sure that we have it in this form, where you have the derivative must be equals to 0. So we're going to equate it to 0. F prime of x equals to 0. Given that condition, when you factor out 6, you'll be left with -x squared plus 9x, and then -108 will just be, I think, 18 times, yeah, 18. So it's -18. Okay, so now we're looking for the factors of this, and we need to kind of like make sure we get it from that information. So this must be equals to 0. How would you factor this equation out? So you're trying to figure out how would you split up 9 in order to get 18. So let me just quickly do that because I am lazy. So I'll just double check. Okay, so after factoring it out, what you should get is going to be x equals to 3 or x equals to 6. Okay, once you have this factored out very nicely, what you can do is start to do the same analysis again. Now, when we draw the number line, the points of concentration are going to be 3 and 0.6, right? So we're going to pick up a point and start to evaluate the value of the derivative at those points, right? So again, just to make it easy, we can write the derivative in the factored form. The factored form will look like -6 factored out, and because you had 3 and 6, you can write x minus 3 and x minus 6. So this is the factored form. There's no difference. All it does is just helps us to find the values quicker. Okay, so let's see. If you pick a value 0 here, what's going to happen? F prime of 0 is going to be -6 times -3 times -6. So it's going to be less than 0. Alright, cool. We figured out those values. Now let's pick up a value in between these two. So let's pick a value, let's probably say 4. 4 will be a good fit. So when you do so, f prime of 4, we plug it in, you get -6 times 1 times -2. So that will be greater than 0. Okay, so we figured out that point is okay. Let's look at 7 for the last part. When you do so, what do you get? When you plug it in, you get -6. And then 7 minus 3 is going to be 4. And then this will give you 1. So essentially, again, less than 0. So now, change the colors. What you can say is, in all of this zone, it's decreasing, right? Because the slope is negative. Same here as well. It's decreasing because slope here is negative. And in between those 2 points, you can see the slope is positive. So it's increasing. Okay, so now that we have all of this, I'm going to make these purple boxes again so that we can easily identify the critical points that we found. So now the interval of increase could be written very easily like this. So increasing on the interval, which is 3 to 6, and decreasing on from -infinity up to 3 and 6 up to infinity onwards, right? From looking at that behavior, you can say those things, and then they want you to be just able to figure out whether it's increasing or decreasing at all those points. In this context, the A value is going to be 3, and then B value is going to be 6. And you kind of know that this is increasing in that interval, and so on, decreasing in the other ones. You can fill in the blanks yourself.